Welcome to homework.
Okay, so in this problem, we have a screw eye and two forces, F1 and F2, are acting on the screw eye. We're tasked with finding the magnitude and direction of force 2, given the magnitude and direction of the resultant force between F1 and F2. So we're told F1 has a magnitude of 80 pounds and it's just along the positive y-axis. We're told that our resultant force has a magnitude of 150 pounds and it forms a 120-degree angle with the x-axis and 130 degrees with the negative y-axis. And we don't know any information about F2, and that's what we're trying to figure out. So we can actually start off by just writing off our information, what we currently know. So for F1, we can break this up into all of its x, y, and z components. So because it's purely along the y-axis, there's no x component to it. Everything is just along the y-axis and the y component. Now for F2, we don't know anything about this yet, so some value x, some value y, and some value z. And lastly, for FR, now we don't really know right now what all those components are, but we can figure them out because we're given the angle and the magnitude. So FRX equals FR, magnitude of FR times the cosine, and for x it's alpha, right? And that's just the angle between the force and the x-axis. And it's the same thing for y and z. But if we plug in 120 degrees into alpha and 150 pounds into FR, we can determine that FRX equals negative 75. So we can write that in here. So negative 75 I. Okay, next we'll move on to y. So FRY is equal to, repeat the same process, magnitude of FR times the cosine of, in this case, it's going to be 130 degrees, and it's beta here. So you plug in 130 degrees and 150 for FR, and FRY will come out to be 96.4 pounds. So we can add that component in, plus 96.4 J. Now for Z, we don't know the angle that it forms with the positive Z-axis, so we can use these two magnitudes and the total magnitude of FR to find what Z is. So remember, when you're looking for magnitude, this is the type of expression you use, FRX squared FRY squared plus FRZ squared, right? And we know this value, and this value, so it should be fairly easy to find FRZ squared or FRZ. So if you plug all of these numbers in, I'm going to put that in a calculator really quickly. You should get a number around, depending on where you're around, a number around 7582 for FRZ squared. So square both sides, and FRZ comes out to be 87.1. So we can fill that in up here, so plus 87.1 K. Okay, now I'm going to make some room. I'm going to remove this work. And our next step is to find what the x, y, and z components of F2 are. So we'll start with x. So 0 plus x has to equal negative 75. Simple enough, right? So x is equal to negative 75. Let's do this with y now. 80 plus y has to equal 96.4. Also simple enough, y must equal 16.4. Lastly, for z, 0 plus z must equal 87.1. So you know that z is equal to 87.1, so that's like a 6. 87.1. Okay, and now that we have all the x, y, and z component, we can find the magnitude by squaring all of them, summing those squares, and taking the square root of that. Okay, I'm just typing this into a calculator, and the final magnitude should come out to be 116.1. So the magnitude of F2 is equal to 116.1, and the unit here is pounds. Okay, our next step is to find all of the component angles. So that's alpha, beta, and gamma for F2. So to do that, we can use this little set of formulas, and I'm going to block this off. So alpha is going to equal inverse cosine of, and just like a right angle trig here, it's just going to be the adjacent over the hypotenuse. So it's going to be the x component over all of F2, or the magnitude of F2. So our x component here is negative 75 over an F2 we determine is 116.1. If you simplify this, alpha will come out to be 0.2 degrees. Next, if you repeat this process with beta, this is equal to cosine, inverse cosine of 16.4, which is our y component, over the total magnitude, which again is 116.1. Now beta comes out to be 81.9 degrees. And I think you get the point now, but we repeat this with gamma for the z component, and that becomes 87.1 over 116.1 on the inside, and gamma comes out to be 41.4 degrees. So those are actually our final answers. So we know that F2 has a magnitude of 116.1 pounds, and these are all of the component angles.